Welcome back to chemistry. And so what I talked about previously was determining the concentration of a solution. And so we do that through a unit called molarity. But there are going to be a number of problems you will encounter probably on your test where you're going to take some kind of concentrated solution and then you're going to add more solvent to it. And you'll add it to a certain volume. And basically what you're doing is you're taking a concentrated solution and making it more dilute. And so what you'll have to do is, based on that information, figure out the concentration of that diluted solution. So I need to show you how to do that. And all this is covered in section 5.5 of your book. So let me talk a little bit about the basic principle of what's going on here, and then I'll kind of go through the math. So the basic principle that is going on is you will have at first some kind of solution. So the solute will be dissolved in the solvent to create a solution. And so you can sort of think of this starting solution as a stock solution. And then what will happen is that for some reason you may want to dilute the solution. And so it's pretty simple to do. All you have to do is just add more solvent to it. And so what will happen is, although the moles of your solute haven't changed, the volume that you've dissolved that solute in has increased quite a bit. So this is sort of a diluted solution, and I'm calling it solution number 2 as opposed to the stock solution, which is solution number 1. So I guess one of the more basic principles that helps you with these kinds of problems is to understand when you're going from a stock solution to a diluted solution, although the moles of the solute will stay the same between those two conditions, the volume changes. And so if that is the case, you can sort of relate solution 1 to solution 2 and solve problems given enough information. So we're going to go to that in just a bit. But before I do that, let me just kind of reinforce some things I just said with a quick example I'm going to do on the computer. Okay, so let's say that I am going to create a stock solution. So I'm going to draw a beaker here. So here's my beaker here. And into the beaker, I'm going to put 50 milliliters of water. So there are 50 milliliters of water in here. And then so you can work out how many liters this is. This is 0.05 liters. Now, what I'm going to do is I'm going to add a solute. It could be anything, but I think in this example I'm saying it's sugar. So what I'm going to do is I'm going to add 5 grams of sugar. And the chemical name for sugar is sucrose. And so the 5 grams will completely dissolve in. And so to represent this dissolved sugar, maybe I'll add some dots here into the water. Now, you might guess that one thing you can do if you wanted to is you can take the gram of sugar and convert it to moles of sugar. So how would you do that? Well, you would have to divide by the molar mass of sugar, and since it's sucrose, that would be dividing it by 342 because there are 342 grams of sucrose per 1 mole of sucrose. But I'm not going to draw that in. I just want to indicate the number of moles of sugar I added in this example. If you work it out, take 5 and divide by 342, you get 0.0146 moles of sugar. So far so good. So let's call this stock solution and solution number 1. Now, we already know that molarity is going to be equal to moles of solute divided by the liters of solution. And so if you wanted to, we can sort of be specific to this solution we're calling it solution 1, so I'm going to put a little 1 here next to these variables here just to indicate that. Now let's say I just wanted to solve this equation for moles. That wouldn't be so difficult to do, right? So what you can see is the moles of solute you have here is equal to the molarity of the solution you have in the end times the volume in liters that you have in the end. Now, we already figured out what the moles of sugar is. We're adding 5 grams, and so this works out to be 0.0146 moles. And so what I'm hoping you see that will be related to the molarity that this final solution is in times its volume in liters. So far so good. Nothing really exciting here. Okay. Now, let's say we dilute this solution. So here is our stock solution here. I'm going to draw it smaller. So in here, again, we have 50 mils of water, and we have 0.0146 moles of sugar because we dissolved 5 grams of sugar in there. So now what we're going to do is we're going to dilute it. So let me show you how we're going to dilute it. So here is a larger beaker. We'll call this first solution, solution 1, which is the stock solution. And then here, this will be the diluted solution, which is solution 2. Okay, so how are we going to dilute this? Well, it's pretty simple. We're going to take the entire 50 milliliters of this solution with the 0.0146 moles of sugar and dump it in like this. And so now it's here. And so the 50 mils of the solution is here with the 0.0146 moles of sugar. Now we're going to dilute it by adding 450 milliliters of water. So now, this was the 50 milliliters of the original solution. Now we have added 450 milliliters of water, pure water, and now we're up to 500 milliliters of water. So what has happened basically is the concentrated stock solution, 50 mils of it, has been sort of further diluted and dissolved into the 450 mils of water. So the question I have for you is this. What happened to the original 0.0146 moles of sugar? Well, what has happened now is it's found more volume to dissolve itself in. So in this second diluted solution, solution number 2, we still have the same number of moles of the sugar. So what we can write out for this solution, diluted number 2, is we can say the molarity of that solution, we'll say M2, is equal to the moles divided by the volume in liters. Now, we can rearrange this equation. We can say moles of solution 2, the diluted solution, is going to be merely the molarity of it times the volume of it in liters. And so you could figure out, for example, you could figure out what L2 is. It would be 500 milliliters total, would be the total volume. But note, again, you're just basically taking the sugar from the stock solution and dumping it in and diluting it. And so all the moles are still there. So we're still at 0.0146 moles is equal to M2 times L2. And likewise, we said before in the previous example, for the stock solution, 0.0146 moles of that is going to be equal to the molarity of that solution, the stock solution, M1, times the volume in liters, L1. So we have these sort of two simple equations, and we can go further with that. So let me show you what we do next. So as I kind of pointed out before, in the stock solution, which is represented by this first equation, it had 0.0146 moles, and it's going to be related to the molarity of the sugar in that volume of water and the volume of the water. And then for the second diluted solution here, it's the same amount of moles in the solution, 0.0146, because it came from the stock. But this time it's going to be related to a different concentration and a different volume. So since those two equations are both 0.0146 moles, they basically can be equated to each other. And so we get a new equation that we can use, which is where 1 is the stock solution, 2 is the diluted solution, that the molarity of the stock solution times the volume in liters of the stock solution is going to be equal to the molarity of the diluted solution times the volume in liters of the diluted solution. So we're going to be using that equation quite a bit in a bit. So one thing that's kind of good to know, and I think it's best to see through examples, is that with this particular equation, what you can do is what I call you can generalize the volumes. And so with the previous equation, what we would have done is add a molarity and liters. Now, what you can do if you want is we can add all kinds of volumes into this equation, just as long as the volume you added to the left side of the equation, the one side, the units are the same as the volume in units you added to the right side of the equation, the two side. So for example, if you were to use a volume on the one side of the equation as milliliters, you would also have to use milliliters on the other side of the equation, the two side of the equation. Or if you used a volume on the one side of the equation of centiliters, you would have to use centiliters on the two side of the equation. So you can use any volume you want in this equation. And so now I've sort of generalized it from molarity times liters is equal to molarity times liters to molarity times volume equals molarity times volume. So what you can go do as well is you can generalize molarity out into any kind of concentration units. So what I've done is I converted M there to C. So the C is to indicate that you can use any kind of concentration units in this equation as long as the concentration units you use on side 1 match the units you use on side 2. So for example, on side 1, if you use molar, which is perfectly fine, you must use molar on side 2. But for example, a lot of concentrations are expressed in mgs per milliliter, or I say mgs per mil because I used to work in a lab. It's actually milligrams per milliliter. And so if you use milligrams per milliliter as C1, your concentration, C2 must be also expressed in milligrams per milliliter as what I call mgs per mil. Okay, so let's go right to some problems. And so we start out again with some easy problems and then it gets a little bit more complicated. Okay, so the first problem is how much volume in milliliters of a 0.500 molar stock solution do you need to create 120 milliliters of a diluted solution with a final concentration that is 0.150 molar. Okay, so this is how you would solve the problem. So again, the basic equation you will use is C1V1 is equal to C2V2. So again, 1 refers to the concentrated stock solutions, 2 refers to the diluted solutions. So C represents a concentration. It could be molar, it could be mgs per mil, whatever unit you want to choose. V refers to a volume. It could be liters or milliliters or centiliters or anything you want to choose is fine. So what I'm going to do to solve this problem is to assign variables. And so I'm going to write out the variables C1, V1, C2, V2. So let's go ahead and assign those. So how much volume in a 0.5 molar stock solution? So we have a stock solution. The stock is 1. It's a concentration that we have 0.5 molar. So that's C1 that's been assigned. So 0.500 molar. Okay. Now we're trying to find out the volume of the stock solution needed to create this diluted solution. And so the volume is what we're trying to find. Now with the diluted solution, we're given some parameters that we want it to be. So we want 120 milliliters of the diluted solution. So V2 is 120 milliliters. And then C2 is going to be 0.150 molar. Now again, just to remind you, when you're using this equation, it is perfectly okay to plug into the equation milliliters, just as long as you realize what you get out of the equation is milliliters. So that is fine to do. So it's pretty easy to solve this, but let's go through that. So what we want to do is solve for V1. So what you can do is C1 is in the numerator on the left side of the equation. When you move it to the right side of the equation, it goes into the denominator. So I'm going to rewrite this. V1 is equal to C2 times V2 over C1. And so now you can just sort of plug in numbers. So C2 is 0.150 molar. And it looks like V2 is 120 milliliters. Looks like we have a decimal there. We want 3 significant figures apparently. And then C1 is 0.500 molar. And so I think if you went ahead and did the division, what you'll find is the answer should be 36 milliliters, but because we're working with 3 significant figures through this problem, the answer should be 36.0 milliliters. Now, I want to talk about, again, why is it milliliters? Well, what you can see is the units cancel out, leaving you with milliliters. So look, molarity on the numerator here cancels out with molarity, the denominator here. We're left with milliliters, and so that will be in your answer. So you can see the units you had to start with in the problem basically just goes down into the answer. So that makes things rather nice. Okay, so let's move on to the next one. Okay. So what is the final molarity of a solution where 5 mils of a stock solution of 0.250 molar is diluted to 45 milliliters of pure water? Okay, so again, sounds like a problem where we're taking a stock solution and diluting it into a new dilute solution. So we need that formula again, C1 times V1 is equal to C2 times V2. So let's assign variables and see where that takes us. Okay, so here we have a 5 milliliters of a stock solution. So V1 is 5.00 milliliters. The stock solution, we know the concentration of. It happens to be 0.250 molar. Now, what we're trying to do is figure out the final molarity. So we're trying to figure out C2. Now, the V2 we have to be careful about. What we're doing is we're taking 5 mils of this concentrated solution, and then apparently, according to the problem, we're diluting that 5 mils by adding 45 milliliters of water. So the final volume in the diluted solution is really 50 mils. Remember, when you have V2, you don't want to put in the number of water you're adding in. What you want to make sure is V2 is the final volume of the solution. So it's going to be 45 mils you're adding in with 5 mils that from the stock solution. So V2 really is 50 milliliters. Okay, and so we're adding 5 and 45, and it looks like I'm going to put a decimal there because there's going to be 2 significant figures. And then after that is pretty much plug and chug. So let's see, C2 is equal to C1V1 over V2. So C1 is 0.250. V1 is 5.00 milliliters. And V2 is 50 milliliters. And so what you can see is the milliliters cancel, and you should be left with an answer in molar. And so I can sort of maybe do the math in my head. Maybe the trickiest part is the significant figures. So it looks like 0.250 molar is being diluted by a tenth. So we kind of, the calculator should confirm that this should be 0.025 molar. So how many significant figures? 3 here, 3 here, 2 here. So it should be 2 significant figures, which I should have. So the answer should be 0.025 molar. But if you want to write this in exponential notation, it'd be 2.5 times 10 to the negative 2 molar. Okay, let's move on to the next problem. Okay, what volume of a 0.5 molar stock sucrose solution in milliliters is needed to create 5 liters of a 0.125 molar final diluted solution? Okay, so again, we're taking a stock solution, we're diluting it, and so this is going to require C1V1 is equal to C2V2. And so we will assign variables as we've been doing. Okay, what volume of a 0.5 molar stock solution? So volume of the stock solution, V1, is what we're trying to find. We have 0.500 is the concentration of the stock solution. And what we want to do is create 5.00 liters of the final solution at a concentration of 0.125 molar. Okay, so what's interesting about this problem is we want an answer in milliliters, yet we're given a volume in liters, and that's okay. So just remember that you can plug in these numbers into this formula, include the liters here, you will get an answer out of the equation in liters, and then later on you can convert that to milliliters. So that's what I'm going to do now. So we're going to solve this for V1. Oh, you have to be careful. I just made a mistake. You have to put in C2, not C1. Don't do what I did. Okay, so 0.125 molar. V2 is 5.00 liter. And then C1 is 0.500 molar. So let's see where we're at. So the molars cancel. We should get an answer in liters. So let's just see what number I get here. So it's going to be 0.125 times 5 divided by 0.5. So I get, at this point, 1.25 liters, but we want the answer in milliliters, and so you will have to convert this to milliliters. So what I recall is I might use this fraction here. This should work. And so the liters cancel, so it's going to be 1.25 times 1 divided by 1 times 10 to the negative 3. So the answer should be 1250 milliliters. I think there's only going to be 3 significant figures, so if you want to write this in exponential notation, it'd be 1.25 times 10 to the 3 milliliters. All right, let's move on. Okay. 4. How much of a 200 millimolar stock solution in milliliters do you need to create 150 milliliters of a diluted solution as a final concentration of 10 millimolar? Okay, so again, a problem where we're going from a stock solution to a diluted solution, so we need C1V1 equals C2V2. So assign the variables. Okay, so how much of a 200 millimolar stock solution? So here, the stock solution 1, or concentration millimolar, C1 is going to be 200 millimolar. So I'm going to write 200. So millimolar may not be a unit you're used to, but we can go ahead and use that. So it's just a little m for milli, capital M for molar. That's perfectly fine. Do you need to create 150 milliliters of the diluted solution? So V2, the diluted solution, is 150 milliliters. And as a final concentration of 10 millimolar. So 10, and it looks like we had 3 significant figures. Millimolar is 203, that's 4 significant figures. Let me put that in there. Okay, so basically what we're trying to find is the volume of the stock solution needed to create a diluted solution with these parameters. So what we're going to do is solve for V1, C2, V2 over C1. So C2 is 200.0 millimolar. Ah! I did it again. Chuckle, chuckle, chuckle. Don't do what I did. But at least I caught myself right. So 10.0 millimolar. V2 is 150 milliliter, 150.0 milliliter, divided by C1, which is 200.0 millimolar. Okay, so the millimolars cancel out nicely. We're left with an answer in milliliters. So let's just see what this number is. So it's going to be 10 times 150 divided by 200. And I get an answer of 7.5 milliliters. And so does this need to be in 2 significant figures or 3 significant figures? It looks to me like this needs to be in 3 significant figures. Is V2? It's in 4 here. So yeah, 3 significant figures. So it should be 7.50 milliliters is your answer. Let's move on. Okay, final question. Let's say you have a stock solution of a drug which has a concentration at 25 mg per ml dissolved in water. How much of this stock do you need to get a 2.5 mg per ml drug solution at a volume of 200 milliliters? How much water would be added to bring the volume of the diluted solution to 200 milliliters? So that's kind of an interesting problem. So again, this is a time where we're going from a stock solution to a diluted solution, so we need C1V1 equals C2V2. Assign variable C1V1, C2V2. Okay. So let's see, we have a stock solution of a drug at a concentration of 25 mg per ml. So it's okay, we don't have a molarity. We can use mg per ml, which is perfectly fine. And so what we're trying to do is find what volume of the stock do we need to create a solution at 2.5 mg per ml and a volume of 200 milliliters. Okay, so we're going to solve for V1. V1 is equal to C2V2 over C1. And let's see if I not make this mistake again. So C2 is 2.5 mgs per mil. Yay! V2 is 200 milliliters. And then over C1 is 25 mgs per mil. Okay, so what it looks like to me is basically what we're going to do is take 2.5 times 200 divided by 25. So I think we can sort of do the answer right now in my head right here. I think it's going to be correct. It's going to be 20 mils. So the question is, how many significant figures at this point? It looks like we're going to have 2 significant figures. Now, this is the volume of the solution, or excuse me, of the stock you need. But we're asked to get another thing. One of the other things we have to get is to figure out how much is this 20 milliliters of the stock diluted by with pure water to give us 200 milliliters of water. Well, that's pretty simple, right? So we want a total volume of 200 milliliters for the final solution. We have 20 milliliters of stock, so we just have to add 180 milliliters of water. And it looks like we're going for 3 significant figures in the 180 milliliters. That should be correct. All right. Thank you for listening. We'll see you next time.